Hi, Heinz.
Hello?
Hi, this is Greg Sivikoff. I just had a thought, and my question was whether there's any benefit in overlapping with the cataclysmic variables section in terms of like merging to have the discussions. I'm just worried about whether or not we're going to have enough people showing up to have a long set of discussions, and the CVs are obviously part of where a lot of the other high energy work gets done. Not all of it, but a lot of it.
Yeah. Well, I asked. There was a survey done at the I think when you registered for the meeting where
Yep.
people could state, and so I asked headquarters how many had selected high energy network, and it were 16. So
Okay.
maybe
Yeah.
maybe you should wait a bit. And I mean, if nobody turns out, I mean, otherwise, I mean, I'm, I'm not so sure we should crash their meeting.
Well, I mean, I asked Sebastian. The thing is, this is partially me being selfish and says that I'm one of the people that I know would want to go to both. And I'm worried that I don't know how much of the 16 has overlap between the CVs, and that's where my
Yeah,
concern is.
yeah, I get there's some overlap with lots of groups.
Oh yes, I'm just thinking if I look at the groups that are meeting right now, though, it's Eclipse and Binaries, PEP, or sorry, photoelectric photogrammetry, long period variables, bright star monitor, and cataclysmic variables. So the clearest conflict is with CVs. But
Yeah,
okay, well, I'll be in the CVs one if it gets really lively in here, and you know want a professional to come in because you want to talk about the pro am, I send me an email and I'll try to monitor my email.
yeah, sure. Or are you on the Slack channel?
Which one?
The one that was, I think there was one for the section leads, and they uh, specifically for the meeting, not the general AAVSO. Well,
Um,
then probably not if you don't know about that.
I was on one for the spectroscopy workshop. Oh, sorry, the spectroscopy workshops, but that one seems to have disappeared. So
Oh,
yeah. All right. So you have the link to the Slack?
yeah, I think you need an invitation, and there might be different Slacks for the different sections. I realized
I,
now.
I would hope they didn't set that up that way.
Yeah,
Okay.
I mean, if there's nothing going on here, I mean, we can just move over. I mean, right? I mean, it's anyway encouraged that people
Move
roam
around.
around a
Yeah.
bit and change rooms and whatnot.
Yeah. Well, if you guys do, then I would just suggest putting like you have your presentation up, just basically saying if you guys do that, just go to that provide the link of the CVs and say that you merged.
Mm,
Anyway,
so
I'm not trying to take over. It's just a brain
yeah, no,
brainstorm. All
sure.
right. Talk to you guys later.
Yeah, okay. Let's see how many turn out here. Mhm. Hello, if you guys have video, feel free to engage your video cameras so that we can all see each other. Hello, Damien.
Hello.
How are you doing?
Well, I am fine. I live in eastern, I would say, eastern northern Quebec, and we have had snow, but it's gone now, so we like it. The grass is still green.
Okay, already in lockdown, or you're still able to move around?
Well, I live in close to a small city, and no lockdown here, but Quebec and Montreal, they are all red, so they cannot move much. But here it's fine. But we are told to stay home, so this is what the majority of people do.
Probably better. Crazy times.
Yes, we are not used to such a situation.
Let's see. Let's wait 1 or 2 more minutes before getting started. Okay, yeah, maybe we should get started, and maybe some more people will join. And I was told that if we feel that we haven't reached critical mass, then the CV section is happy to have us move all to their room. But yeah, let's wait a bit. Let's see whether more people are turning up. Yeah, maybe I should introduce myself, because I think the only name tag that you see is AADS05. So that's not my name. My name is Heinz-Bert Eckenstein. I'm now, since a few days, I think, co-lead of the high energy network section. Yeah, and was asked to host and moderate this section a few days ago, so it came a bit of a surprise, but yeah, let's try. Yeah, since we are so small a crowd, we can go around and everybody can introduce him, herself. Yeah, just just let us know who you are, perhaps in any order.
Okay, maybe I can break the ice.
Yes.
Okay. Um, well, I have been an amateur astronomer, I would say, most of my life. Being retired now, this is what what I do most of to use much of my time. I have a permanent observatory. I've been doing variable star observing. I would say quite heavily for the last 6, 7 years, providing data to CBA and of course AVSO. And 2 years ago, I was lucky. I was given an old setup to do spectroscopy. So now I am learning spectroscopy with a LIRS-3 from Chiliac. So I'm still learning spectroscopy, but I feel that I will be close to what I would like to be. Soon I will be where I aim to be. Thank you.
Cool. Thank you. Leslie, you want to introduce yourself a bit, perhaps?
Hello, everybody. I am Leslie Brown. I'm the director of a small observatory on the campus of Connecticut College. I'm also a professor of physics and astronomy there. My students and my graduate work was in um, active galactic nuclei. So I did some of the early, maybe even pioneering work on very long baseline interferometry of blazars and other types of active galactic nuclei back in the day. But when I started working at Connecticut College, I was immediately upscattered into the optical. So I got kicked up into higher energy from the radio and to optical, and now we do optical monitoring from our facility, and also we use Gary Walker's facility out at SRO for remote observing, especially now during COVID when we can't really get kids to the observatory. So it's actually, remote observing has been such a blessing. It's allowed us to continue research. So I'm not sure whether I belong in high energy or what. You know, you could say bulk relativistic flow, yeah, high energy, but those photons are low energy. So, but we're actually interested in looking at, if you've checked out our poster, I have a freshman and a sophomore who are presenting their first research ever. So they're looking at both optical data and gamma ray data and trying to look at time correlations between the two to see if we can understand whether stuff like synchrotron self-compton in situ in the jets is producing the gamma rays, or whether it's happening in a large halo around these objects, or whether it's actually all kinds of weird particle decays that might be doing the gamma ray production. So that's what I do. And so I've got telescopes. My living room is filled with telescopes, telescope parts. We built our own CCD camera way back, with God bless Richard Berry's first cookbook came out. We did our own way back then. I'm an active member of the local astronomy club. I go out and just look at stuff. We do astrophotography with our kids, name it. I am the chief cook and bottle washer. I do all repairs, all computer programming, everything at my institution, with help of my students who are wonderful. But so I've got an interest in almost everything that anybody's done here today. So
Great. Well, that sounds like you're in the right place for AAVSO, light curve wise and everything. Then there is Mac user. I don't have your name. Could you introduce yourself briefly?
Sure. I'm just observing. I was someone named Lindsay at AAVSO. It recommended that I check out the group, so I thought I'd just randomly choose a breakout and watch. But yeah, thanks so much.
Next on my list in no particular order is John Murrow.
Yeah, hi. I'm a retired engineer. I'm a bit of a fraud here because I can't really declare I'm an observer. I live just south of London. It's heavily light polluted. I'm lucky if I can see anything. Orange skies. I tried to look for the comet last night in Orion, couldn't see it, even though it's magnitude 8 with binoculars. So my interests tend to be data mining, and I'm here really because for years ago I've given quite a few lectures to various astronomical societies, and one of my interests was gamma ray bursts in the past. And one of my other interests at the moment is I'm working with some professional astronomers looking at the output of the so-called or the software that looks at events happening on large telescopes, so-called event brokers, and they're now trialing an event broker on ZTF, which is going to get onto LSST eventually, hopefully, where they've got the money for it. So I'm fishing my way through what comes out of that to see what's interesting and what's totally boring, and then feeding that to various people I know to try and follow it up. But obviously, eventually that's going to all be automated. But at the moment, the event broker produces random rubbish, could I say, if I want to be very nice about it. Well, you know, it's got lots of curves coming into it. It sees a light curve and has to try and say, what the heck is this light curve? And shall I tell someone about it? Because when we get to LSST, and, you know, we haven't really talked about professional programs, we're talking about, what, 1 million alerts a night or something stupid, or 1 million variations a night. They're going to plop into plop into the software, and somehow we're going to have to aim a few dozen professional telescopes at those. So that's one thing I'm doing. The other one I'm doing, I'm involved in citizen science in, I don't know if you've heard about Galaxy Zoo, have you?
Yep.
In Galaxy Zoo, I'm doing some beta testing on looking for the long duration high luminosity supernovae. There's a new there will be a new citizen science program coming out on there, looking at light curves from ZTF, and says, is this a superluminous supernova? Now, I'm not sure which group superluminous supernovae come in, but we'll call them high energy, shall we, for the moment? That's about me, really.
Ah, cool. That software is not by chance the Kowalski thing that is going on at ZTF. They have a pipeline named Kowalski after the penguins.
Yeah, no, this is one called LASEA that's being done by the Royal Observatory in Edinburgh in the UK.
Oh, okay.
There are, I think, 3 or 4 pipelines going on in parallel.
Cool.
And there's some hope that one of them may produce these various, I think they're using artificial intelligence for one, they're using various other methods for others. Hoping that one will actually reduce the flood of data to something sensible.
Nice. Cool. Thank you. Pierre, can you say a few words about yourself? If you want. I think you're muted.
Yeah, okay.
Cool.
Okay, I'm living in Belgium. I'm an amateur astronomer. I'm mainly interested in R stars, and I wrote the photometry program called LESV photometry that is used by some people in the AVSO community. Yeah.
Thank you for that.
Yeah.
I use it like almost every clear night. That is so cool.
Okay, thank you.
We really appreciate your work. I'm very interested in doing transformation on ensemble photometry because it's for many of the large campaigns. Ensemble photometry is part of what has to happen, and to try and do the color transformations in from ensemble work is a bit of a programming challenge. And so given that you've done it, is greatly appreciated.
That's okay. I always appreciate feedback, and if you have suggestion to improve the program, okay, because I started, I think, about 10 years ago or something like that. And so in the meantime, the program is improved by suggestion from observer. Yeah, thank you.
Cool. Adam, could you say a few words about yourself?
Sure. Sure. I'm just an amateur. I don't work anything to do with astronomy at all. I do have a couple of telescopes. Recently started in astrophotography. I think this, I guess the science with high energy sounds really interesting to me. So that's why I chopped in today.
Okay, cool. Okay, Todd, could you say a few words about yourself? We are just introducing ourselves a bit.
Sure. Hi. So I'm just sort of browsing around all the sessions. So I teach astronomy and physics in Oregon, and I mostly do research on education kinds of related things. So we're doing a project on getting people involved with looking at exoplanet transits. So anyway, so I'm just kind of seeing what people are up to, seeing what's going on.
Cool.
Thanks.
I think the last I think I haven't called yet is Wyatt. Could you say a few words?
Hi, I am a student in college under Leslie Brown here. I'm an astrophysics major. I've just recently actually put in my first order for a telescope. I'm still somewhat new to astronomy. I've been doing it for a bit over a year. Somewhat new, not super experienced. I've done primarily astrophotography, but I've been doing photometry with Dr. Brown here. And yeah, that's me.
Cool. So just to get the discussion going a bit, I had prepared a few talking points that we can go very, very fast. I don't want to do a presentation here. I mean, that's boring, but let's see if I can share my screen. I should have probably started that thing before. Probably you see my presentation screen, my presenter screen. That's not what I want. Bear with me. Let's try this one. So you should see some slide, right? Can you see a slide?
Yep. Great.
Yes, we can see.
Cool. Yeah. So I think what we might talk about today is, and I think that overlaps nicely with what you have described as your interests. I mean, first, I mean, some people might be new to the group. What are the type of objects that we are interested in and that are fun to observe? Because I mean, we are all doing this. It should be a fun experience, right? I mean, most of the objects are transients that are interesting, and some of them decay rather fast. So it's kind of important to get messages about new interesting alerts out to interested observers quickly. And yeah, that can be quite a bit of a challenge. And then I would like to also talk about our science impact, because I mean that are the two things, right? I mean, we should have fun observing stuff, but we also want to do it not just for our pleasure, but we want to share some science. So that is our official mission statement that is pinned to the head of the header of our forum, and I won't read it out. So you will just notice that I think historically it started with gamma ray burst follow-ups, but it's also intended to cover blazars and other AGNs and flare stars and X-ray binaries. it should be open to new phenomena. Like I would think that the cow and the koala, the events with those nicknames would also qualify as high energy events. Gravitational wave events with optical follow-ups, and potentially sometime maybe even neutrino follow-ups. The problem is, and I'm interested in hearing your opinion about it, what we can actually demand of our observers to watch is, I mean, theoretically you would have to have an eye on ATEL, on GCN, on transient name server. When there's a gravitational wave campaign, there's GraceDB, there's also our forum in the AVSO, there are AVSO alerts going on, so that's a lot of stuff. And yeah, there are ideas for having a smartphone app that I learned about in a conference just earlier this week, ADAS, which is called Colibri, which would actually alert you about interesting events, and you can configure it so that you are not alerted about events that you cannot observe anyway because they are in the wrong hemisphere, etc. So that would be something that I can show the poster of if someone is interested. But I think that would be nice to have something like that, so that you can. I mean, that's one of the advantages of us amateurs. I mean, if we want to observe something, we don't need to ask an observatory director for telescope time. We just go and observe. So our science impact. I have a nice case study here that is an ATEL that was put out in May, 7th of May 2020, titled Bright Optical Flare in the Flaring Gamma Ray BL-LUC S5 1803 plus 784. And if you have ever been to our forum, that is about one of the two objects we have been observing in detail, perhaps, which there were discussions on the forum. And this ATEL was reported two measurements in red filter with a 100-inch telescope, the NOT, at two epochs, one day separated, a bit in the past, like in April. I mean, as I said, the ATEL was on in May with a standard deviation of 0.02 magnitudes. And let's see what our light curve was at the time of that ATEL. So the telegram came out here. The measured epoch was here, and reported two data points here. And I mean, those were professionals, and I think that is not so good, because I mean, if they would have been aware that we have made all those beautiful measurements, I mean, maybe they would have either cited our data curve, or maybe they would have done something with us, or maybe they would have thought, oh, well, maybe I don't need to report those two data curves at all. And I mean, at the point that they reported, the light curve was already rising again. And maybe that would have been more interesting. So somehow the pros don't seem to be so much aware of what we are doing, and maybe we may want to share, want to change that. I mean, other groups other amateurs are actually doing ATELs themselves. Should we do that? Maybe we can discuss that. Or we could team up with the pros, and like in 2021, probably running through 2023, there will be a cooperation that there will be a citizen science project again from the Grandma collaboration. I love that logo. And yeah, maybe we want to participate in that. And I think they are also in talks with the AAVSO management about some collaboration. And yeah, so we could do things like that. So that was a lot of stuff to get us started, I guess. So yeah, feel free to throw in your comments to any of those points.
I suppose my safe thing would be with the ATELs, exactly how that would fit into the sort of AVSO structure. Would it be your job to look at the observations coming in and write the ATEL and post it, or because it's hardly going to be likely to be individual observers, is it? I don't know. It's difficult because obviously a lot of those are done by large observatories and produce a few data points in ATEL normally.
Yeah, that's a point that I also am struggling with, because I mean, starting with who would be the author. I mean, ideally, all the observers should be authors. But I mean, if you have seen the author list, the observer list from that that last thing I showed, before you have contacted them all and asked for their permission to do an ATEL, yeah, probably it's no longer relevant. But on the other hand, I mean, like people like Tony van Munster in this CV section, like when they spotted a brightening of SSN18EY, Maxi 180 blah, 1820 something, they wrote an ATEL. And that was totally justified, because they were the first to notice that this thing is rising again. And I think it was also an amateur that noticed that S5 blah was rising again. So I really don't have an answer how we should, or we could write ATELs about that in a way that is correct with authorship.
The thing about an ATEL, it's got to be almost instantaneous, hasn't it? So it's almost up to each individual observer, because if you look at what happens with the professional reports on there, or they're not all professional reports, is that they're written that day, this happened last night. Yes, or this has just happened a couple of hours ago. So almost each observer is going to have to do it, which is going to be quite interesting, because they're going to have confidence in what they've actually seen.
And the fact is that a lot of the professional observatories have staff that are going to be staying up all night analyzing that data and producing an instantaneous result that they are confident in. And the problem is that if you're producing 1 or 2 data points for a given object, you may not know yet, because it hasn't been verified through the whole AVSO process, if anybody else is seeing that. So you might not feel that confidence. And so ATEL reports might be best done through, if they can manage it, I don't want to ask them to suck down more of their endowment, but through AVSO headquarters, if they're verifying the data and they see a trend, something happening, they should alert everybody right away and say, we should get an ATEL out about it. But I think an individual might feel a little less confident to do that. And if they, hey, I'm sure we all have data that has been sitting in our shelves for 10 years, and like Richard, and we haven't had a chance to analyze it yet. Sometimes you just don't have that chance. So it's really getting it out in time.
Yeah. I mean, it would also be an option, I guess, if one could collaborate with people like I mean, like the object I showed earlier is under constant watch from Fermi. And what we actually did was, contacting some people who've written ATELs from that's Goddard Space Flight Center, right? whether they wanted to look into our light curves and link them and be interested to cooperate with us. We didn't get an answer yet. Okay, there was a public holiday, Veterans Day, blah, blah. But yeah, there still is, I get a bit of reluctance to work with amateurs, but I guess one has to keep trying, right? Yeah, I mean, so that is the that is us notifying the outside world. I mean, the other aspect is how do the observers get information about new events? I mean, currently, I mean, there have been 1 or 2 cases where that was put in the forum. And I mean, there is a mechanism by which you can subscribe to forum things. So you can, you will get an email. But so I wonder about this smartphone app. Is that asking too much, or is that too stressful? If amateur observers would have this smartphone app installed and they get an alarm when something that they configured, it might be interesting for them, is within their observation range.
Something similar to that was done by Sky and Telescope a long while ago, wasn't it? But by sending you emails if certain things happened. I'm not sure whether they still run that or not. So if a new supernova was discovered, they theoretically would send everyone onto the subscribed list saying this has happened. But I think the problem with high energy transients, and that's what this section's about, is of course a lot of them are very quick. You've got to be there very often within, well, the gamma ray bursts, of course, within an hour or 2 or half an hour or something stupid of the gamma ray being discovered.
Yeah, but I mean, imagine that if you're already out there observing, and then the next day you read that at that time something interesting was going on, and you missed it. I mean, how bad is that? So
I don't want to interrupt. I think it's a great idea. I'm just going to join in and think. I think it's interesting. It's fun. Even if you're just, even if you can't observe at that moment, you can at least look and see and feel excited. Look on your phone and say, oh, this is happening right now. I think there's value in that.
Yeah, and maybe I'm too old school. I mean, I kind of think like, isn't that totally intrusive? But I mean, all the people nowadays have constant alerts on their smartphones when somebody has.
And I assume you can turn it. I assume you can turn it off.
Yeah,
right?
sure. Mm-hmm.
So if you have it on, it's because you're interested. People get Facebook alerts and all sorts of things. I don't think it's that intrusive.
Leslie?
I would really like the smartphone app. I know I cruise ATEL and have it set up to send me alerts, but they come into email, and I get the alerts from Fermi about objects I'm interested in, and they come into email, and of course there are like 100 other emails there, and so it just sort of gets lost. And it would be really nice, no matter when, to have that alert come up, so that if we've got the ability, and especially people with automated systems, to just turn it on, get it going. I would find it very useful, and as has been said, you can turn it off if you really are getting annoyed by it. I mean, let's face it, how many of these types of programs are out there? You can go on Space Weather and get signed up for alerts about aurora. As John was saying, you can get alerts about supernova. So I think this is something that would be very useful, and maybe AVSO should have something like that for critical events in any type of objects that the AVSO is interested in following, to alert members of that particular group or subgroup that it's really timed up. If you've got data from yesterday, great. If you've got, can get on it now, wonderful. And we've got people all around the world. So you've got essentially you've got complete coverage, hopefully, if people are on.
Yeah. So as I said, I met some guys on a software conference this week, doing this Colibri thing, and I asked them, and I was already prepared to be rejected, like, would you like amateurs to have this? And they said, yes, very much so. And so they are about to get out a beta version of their app, and the guy that I met there promised to send me an email when the thing is out. So, and then I guess I will then post it on the post it in the forum, so we can be beta testers and try to steer this project in a way that is user friendly for amateurs, right? That would be really cool. I like the aspect that you can, yeah.
Oh, I'm sorry. I was just agreeing. It's a good point that it's all over the world. I live in Paris at the moment. I'm from New York, but I live in Paris. So I might be up and in front of my equipment at a time when someone else is in bed. So you have coverage all over the world. It's a good thing to take advantage of, I think.
Yeah. When there was during the last gravitational wave run, when there was the gravitational wave detectors up, and they gave out real-time alerts about events they found, and yeah, everybody hoped that we would find another optical counterpart to it. Yeah, actually, there was an app for it, but I also built a little thing that was sitting next to my TV with LEDs and beepers, and I'm not sure if I can see that here. No, it doesn't work with the background. Now, yeah. So with a process that watches GCN things, and if something comes in, it would beep and stuff. But yeah, it would be so cool, I think, to have a professional built smartphone app for that.
Of course, that's what these event brokers are going to do in some form, but they're really designed to couple directly to a telescope. So your telescope will observe and you can just stay at home, really. You don't need to go anywhere near the telescope. And theoretically, the results are there when you get up in the morning. But of course, the big problem is, most alerts are faint. And one thing I didn't actually mention the Gaia alerts. I've been looking at the Gaia transient alerts as well. One thing that's come out of looking at those is that for every magnitude, the number of alerts doubles. So there's more alerts in the next magnitude bin, yes, than there are in all the previous bins. So the vast majority of the alerts are 19th magnitude, 20th magnitude, somewhere down there where Gaia falls off. And I think LSST is going to be the same thing. So you can expect vast numbers of 19th, 20th magnitude alerts. That's one of the things I'm looking at with LASER at the moment, is you can obviously cut the alerts at a very high level, but then you don't get many alerts, even at 16th magnitude. But that might be a function of the way the event broker's working at the moment.
Yeah, I guess they would be more tailored to the professional needs and not so much.
Well, I think they're meant to be flexible enough that you can actually put your own parameters in. If you only want 15th, 14th magnitude alerts, and you want supernovae, because what they're trying to do is classify them into what they think they are on the basis of a bit of artificial intelligence and various other things. That's the bit that's not working very well at the moment. So you get some very interesting predictions coming out. So it says, you look at that curve and you think, well, that's not what the software thought it was. But bearing in mind, it does it on the first 2 or 3 data points, and you may well be looking at a few data points later. So you've got quite a lot of advantage over a bit of artificial intelligence.
Yeah, that's. But I mean, on the other hand, the bright events will be potentially the interesting ones, because there can be so much more science being done on that, like spectroscopy and whatnot, and they will be closer, and they will be observed longer. Like, I mean, already ZTF is producing so many alerts, and only a very small fraction of that is actually studied in detail, right? Because it's just too faint, too many. So I think there's space for amateurs. Like, such a shame that the first counterpart for a binary neutron merger that was triggered by a gravitational wave event happened at a time where all the alerts were not public, because that was an event that started at 16th magnitude, and next day maybe it was 17th, 18th. That would have been totally in the capacity of amateur astronomers, and it took the professionals like 10 hours or so from alert to finding the thing. And because it happened on because I mean all the big telescopes more or less are clustered in Chile now, and a few in the Canaries and whatnot. But amateurs are all over the world, right? So yeah, I'm looking forward to this Grandma kilonova catcher collaboration. And if for those who haven't heard about this, that is again something that is hunting for the optical counterparts of binary neutron star mergers. And the way they hope it will work is that you they send you an alert with and unfortunately the sky localization is not very good for these alerts, so they will give you a rather big portion of the sky, and then people will have to cover this and make lots of images, which are then explored to actually find the source in the first place. And this project will be like you make an exposure in a certain part of the field, then you upload it. You don't have to look for the transient yourself. And yeah, that's it. So it will be very user-friendly, very it will be okay for people who don't have a photometry background and who might become more from pretty pictures, but it will be very rewarding if you find something, because I mean it's probably rare, but if you find something that will be very, very important to find quickly, so that the pros can study it fast.
Do you know what they intend to use as a comparison field? Because of course you can't just use an ordinary sky field, because you've got every variable in it will get flagged up if you're not careful. So I don't know if do they use a catalog, or do they use I don't know how you do that really.
I think they do differential, the difference photometry with pan-stars maybe. So they actually compared with images from the field, and because these things should happen near known galaxies, they can then further limit it to well, if it's not in the vicinity of a known galaxy, it's probably something else. So that's how they've done it during the last run.
Yeah, I think one of the interesting things that comes out of the Gaia alerts is actually that there's a lot of blue, what they call blue transients appear, not near any galaxy. They just sort of suddenly a sort of 19th, 18th magnitude blue looking something will appear, and then it disappears again. Whether it's a CV that's just got above a threshold, or it's too fast to be something like a supernovae, but it's not really clear what they are. But there's 10% of 13,000 odd of something like blue transients. It's quite frightening. We just don't know what they are.
But they are sure that it's astrophysical, or could it be?
Well, it's a satellite. It's a city in space, so it's not got any atmospheric stuff in there. And
Yeah,
I
like
think they eliminate most asteroids and things like that. Obviously, and quite a lot of them have 2 measurements, 3 measurements of it from the satellite. Because the way Gaia works is it tends to scan around the same thing twice with a 6-hour gap between them. So, you get 2 detections. So you're fairly certain there was something there. And there's so many of them that they can't just be random things, but they could they could be CVs that have just about crept above the sort of 20th and 19th magnitude threshold.
cool and frightening, as you said. It's interesting and puzzling.
Say there's I think Gaia's found 13,000 alerts in 3 years, and that's only a very small subset that they've decided to publish. So worthwhile having a look at if people haven't looked at the Gaia transient alert page. You can spend hours looking through curves thinking what the heck's the shape of that. There's micro lensing events there that have happened and no one's ever bothered to follow up, and all sorts of strange things.
Cool. So I see some new attendees. Philip Romanov, I saw your presentation. Was it today or yesterday? Very, very cool stuff. Congratulations on finding that variable, and hopefully some more. So any other thoughts about where our section should go in the future, and what we could do to, I don't know, to attract more people participating in the forum? I mean, if you look at the observer list from S5 1803+78, I think there are like 20 or 30 now, and I'm not sure how many people ever wrote something in the forum. It could be more like 3 or 4 or 5. So how can we change that?
Can I ask a different question, actually?
Sure.
Sure. I just wondered, what kind of equipment do you think is actually needed to be able to participate? Like maybe one question that I've always been wondering about is like what kind of image scale is actually needed?
Yeah, Leslie?
That's a complicated question. It sort of depends on what your conditions are above your observatory. So what your seeing conditions are. Image scale is going to be, you have to think about how many arc seconds per pixel you want across a dot of light, whether you're looking at a variable star or an active galactic nucleus, whatever it is, you want hopefully to get more than 1 pixel on that star profile. So typically when you start to think about a CCD camera, you're looking to try and get good sampling across your Gaussian star profile. I mean, it would be Poisson, but if you get enough data points, it looks Gaussian. So it depends where you're observing and what your sky conditions are. If you've got 1 arc second seen, then you can have pixel sizes given. I mean, there's a formula that's in the CCD manual that says that your image scale is essentially in arc seconds per pixel, 206,265 times the size of the pixel divided by the size your focal length in the same units. And if you you want to set
Sure.
that.
I'm familiar with that stuff. I was trying to figure out like just for like the purposes of this particular section, you know, well, my impression is you're looking at stuff that's really faint and tiny, at least, you know, from a angular. So I'm just trying to get a sense of what it is. I know like what my equipment is capable of doing in terms of pitch and miss scale, and I know like what the seeing is here. I'm more or less under the jet stream most of the time, so not good. but you know, so
Yeah.
but I can sample. But so I'm just trying to figure out like, do I have the right equipment to even, you know, participate or
You do for active galactic nuclei, because some of these objects are not a huge redshift. And so they have both the nucleus, which you know may or may not span 1 or 2 pixels, but they've also got the extended galaxy around them. So you can certainly do that. You might not getting anything on some of these things like the gamma, afterglows of some of these gamma ray bursts is better than nothing. So I would say if that's your interest, I'd say don't worry about so much, just see if you can get some data. And then other people collaborating with you can help improve that data. So that would be my suggestion. It depends on what object you're interested in looking at. What types of objects?
I guess I don't really know yet.
It's just
Trying
has to be
to learn from
variable,
others.
right? So cool
Right.
stuff.
Yeah.
Like let me give an example. The object I showed before that the researchers wrote an ATEL about, where we in the AAVSO had this wonderful light curve that is also an active galactic nuclei in that flares. And
Sorry, can you turn on a chat? I would like to write about my observations of gamma ray burst, but my English is not very well, and I don't speak it.
yeah, I understand. I'll turn it on.
Okay, thank you. I write it.
Okay. In the meantime, let me briefly answer Adam's question again. So that object that I showed before, when it's between flares, it's like 16.0 to 16.5-ish magnitude in V band, right? So that is totally doable with a 6-inch telescope, with an 8-inch telescope. I personally have an 8-inch telescope, and which is small, and a CMOS camera, and so it's a pretty medium-sized portable thingy, right? And as long as you don't want to do high cadence time series work where you want to have a data point like every 10 seconds, you can do a lot with an 8-inch telescope. Yeah, Leslie?
So would you say what your exposure time is with your equipment set up in your 8-inch and where you're located? So that would maybe give Adam an idea of what's possible given where he is and what equipment he's got.
Yeah, so I'm under a suburban sky, not really dark, and I co-add as many frames as I need to reach a good signal to noise ratio, which can be as many as 20 minutes, and I do that in 16 second frames, which I can do because I have a CMOS camera and it has low read noise, so you can get away with making lots of images, and when there is a cloud coming through or whatever, you just lose a bit of the observation time, or the guiding doesn't work and whatnot. So yeah, that I have this. I think that's a great rule of thumb. That is like per every square centimeter of aperture, a 0 magnitude star gives you like 300,000 photons per second. So 300,000 photons per second per square centimeter of aperture, roughly, magnitude-wise. And you for each data point, you want to have like 10,000 photons. And from that, you can work out at a given aperture how long you want to expose. Right? So now we can look at the chat and see. Let's give it some. That's a lot. Wow. That is impressive, and I think it's encouraging. Like you can do really impressive stuff with equipment that is still within the range of amateurs, right? But I mean, even if you think for a given target, your own telescope isn't quite up to it. I'm not sure how many people here are using iTelescope time. But I mean, it's kind of expensive, but at least it's an option if you want to follow up on something. But you have clouds in your own site, and or it's in the wrong hemisphere or whatever. There's this possibility now of renting telescope time with companies like iTelescope, and typically with telescopes that have like half a meter or 40 centimeter aperture, and sometimes I do that when I'm too frustrated with weather here in Germany. So Philip, one question for you. I think you can understand me, right? So how many unsuccessful tries to follow up gamma ray bursts did you have before you succeeded? Like how often have you tried that and not found anything until you got to the point where you found something?
I write it.
I see. Cool. So you're also using iTelescope. Nice.
it was a bright gamma ray burst, and optical afterglow was long, and after a day, I observed it.
Okay, and this, Leslie, this 3 years of data, is that already in AAVSO database, or is that proprietary?
When we're waiting to see what we collaborate with the Whole Earth Blazar telescope, so it will depend on what they decide. Once they say it's fine to do, it'll go into AAVSO. But we're waiting to, because there's a big campaign on BLAC through that historic outburst. So simultaneous observations with gamma ray telescopes and optical telescopes to try and understand a little bit more about producing the high energy radiation from these objects. So we're waiting to see, but then it'd be nice, because I know for what we're doing with my students, we're looking at the AAVSO database to pull the long-term data we get from that. Unfortunately, the monitoring group of professional astronomers around the world, they're doing this like R band, and AAVSO likes V band. So we'll have to do some color fudging stuff and play around with it a little bit. But it helps if you're just looking at time delays, then the band doesn't matter so much, especially if they're close like VNR, wavelength space.
Yeah, I was always puzzled, like what filters would be most useful to the professionals for those objects. Like I mean, for S5 blah, we now have, I think, good coverage in even 4 filters like B and R and I. R seems to be a bit out of favor with most observers, I guess, because it has a rather weird filter curve, and it's also so different from the new Sloan R filter, right? So if we can decide, I mean, we can decide what time to invest in which filters. I mean, what should we do from your point of view?
Well, I think as much data as you can get across any of the filter bands would be useful. As got mentioned on the talk yesterday or the how-to session, a lot of what happens is when the professors are going to start with one telescope they're pretty comfortable with, do the color corrections, the transformation coefficients there, and then they're going to adjust the rest of the data. Because if you've got 30 telescopes around the world contributing to a long-term monitoring campaign, color transforming everything is going to be tough and maybe difficult depending on what filters people have. So there'll be some adjustment once there's some standard set. Because one of the interesting things about at least the active galactic nuclei, the blazar objects, is that there is a color change during flaring. Not a big surprise. You expect it, more energy to go into shorter wavelengths when an object is flaring and shooting probably relativistic blobs down the jet and upping the synchrotron radiation and getting inverse Compton scattering. So color is important, but from what I've seen from the groups I monitor and have worked with, is that R was the preferable one, the cousins R. At least that's what people had reported a lot of, but that may be changing in the future again, equipment filters change very rapidly, so who knows? But because of historic data sets, that our filter has been calibrated. So there are standards in the fields of all these BLAC objects, which are well known to anybody who works in the AGN fields. So University of Heidelberg has a huge set of these finder charts with the calibration stars in them, and R-band is just part of that. So our cousins are. So that's why I think it's one of these historical anachronisms. May not be the best, but that's there. But certainly V is useful. So, and in fact, it's all useful. So whatever you have, use it. I think that's the thing. It's always more data, isn't it?
Nice. I'm wondering, would you think that some of the professionals in your collaboration would like to make campaigns together with astronomers, with amateurs, like a formal campaign to watch a certain object, or not like we sometimes have in the AAVSO?
I don't see why not. I think they do like to have some consistency between people who are members of the campaigns, so that they can understand the quality of the data that's coming from the people whose data they are using. So as AAVSO vets a lot of the data points before posting them to the AID for use in VSTAR, they also have to do it. And so I can say I don't see why not, but it may take some vetting to get that to happen. And it depends on, it's certainly, when I talk to the campaign again, I'm certainly going to mention it, that if they are lacking time coverage in certain areas, then perhaps there are a couple of observatories as well as the AVSO that do this and just have beautiful light curves, and it really does need to be mined for data.
Yeah, I mean, I think we have now a light curve that we can do a sales pitch with. I mean, if you look at the S5 1803 plus 78 light curve, I mean, there's hardly a day without measurement in the last 300 days or whatever. Certainly since the first outbreak this year. So yeah, I mean, if you have if it fits the conversation, and I mean, you could somehow present this light curve to people who might be interested, and I mean, then they can see for themselves whether that is something that is good enough for them, and whether it would be interesting to do something like that. I know it's a particularly bright object, I guess, but yeah, I think we can. The group can be, or the AAVSO can be quite proud of that light curve. I mean, it looks quite good to me from coverage point, and there are even some stretches with time resolved high cadence measurements. So yeah, feel free to show this around to some professionals who might be interested.
The thing is to find out who is doing that source, or doing some program or research activity related to that particular source. But it's certainly a good example of what can be done. And if the data has already been vetted by the AAVSO, then we've got a good sense of the type of quality that is present in the data. So that hopefully will be very encouraging, and hopefully we'll get that more of our data used.
And the good thing is that it always the observer code is stored with the data. So if you see that there are some observers who have maybe smaller telescopes and have errors that are bigger than what you want, I mean, you can always not include that in your research, right? I mean, you don't have to take all the bulk of the data. Okay, cool. Yeah, I think we have already reached our, I think that was the strange sound that played a few minutes ago. We have reached our end time, but I mean, I've some more minutes. I mean, please, I by no means feel obliged to stay here, but I mean, if somebody has something to discuss still, I mean, please feel free to bring it up.
Thank you, everybody. I'm going to take off. I appreciate you letting me sit in and talk, and I'm happy to be looking forward to being part of this group.
That would be really great to have you with us with your professional background.
Well, it's, yeah, don't count on too much of that, but but I am I'm happy to help where I can. So anyway,
Yeah.
take care, everybody.
Okay, see you.
Thank you.
Okay, I guess if I think we have discussed a lot of points, and I'm looking forward to have more discussions in the forum and data and whatnot. So yeah, I think we can wrap it up here, and I think it's a bit unfortunate that we don't have a closing event for the AAVSO conference, because I mean that is now basically the end of it. So yeah, see you. Yeah, all of this will, I mean, we will have a meeting of the section leads with the AAVSO management, and I guess one of the points to discuss is whether we will have observer section meetings in Zoom in the future. I mean, we are doing this now because we have to, because of COVID-19, but yeah, maybe something of this turns out to be useful even afterwards. It's difficult with time zones, but
it's more difficult to fly for everyone to fly somewhere.
Definitely. I mean,
you know, we've had people from, well, one from Russia, several from America. You from Germany, are you?
Yeah.
Young lady from who's in Paris. You know, if you just add the airfares together for us meeting.
Yeah, so I
we've got Belgium as well at the top.
Yeah, I'm not sure how you think about it, but I personally would like it to have this. I don't know at what cadence, but I wouldn't mind this happened every few months or so.
No, I agree with that. Could I just ask one thing about, you know, the very first slide you put up about the sort of rationale of the section?
The mission statement.
The mission statement, yeah, that's the thing, isn't it? One thing that's not on there is supernovae.
Yeah, exactly. I was.
Which section do they sit in if they don't sit in here?
I was kind of struggling with that because I mean that's interesting actually.
I think that's the thing you probably possibly ought to take to the management of the AAVSO, because yeah, I know a lot of supernovae are quite boring now. That's why a lot of professionals just ignore them. But you know, the in thing at the moment, the ones I said I'm looking at, is these superluminous supernovae. And the thing about those is they've got a rise time of 20 or 30 days. So they, you know, they're quite interesting objects.
Yeah, and they that's probably longer than the attention span of many professional astronomers, right?
Well, that's why they're coming out of things like ZTF and be coming out of LSST, or sorry, the Vera Rubins Observatory now, isn't it, VRO? That's why they're going to find them in there and hopefully follow them up before that. Someone will follow them up before they sort of peak.
No, that's a good idea. I'll ask the management where supernovae, because I actually looked for some of the more bright supernovae where they were discussed in the forum, and for some reason some discussion was in the CV section because a CV observer had just by chance found it, or in the NOVA. Because supernova. Right?
Perhaps there ought to be a transient section rather than a high energy section. I don't know. You could have.
Yeah. Yeah. I mean, most of the high energy thing is transients. Most of the transients somehow are probably in some way high energy. I mean, there's a whole class of supernova that have a gamma ray burst as a precursor, right? So I wouldn't mind if that was in our section. I mean, it's not that we are overwhelmed with participation in the forum. Why not? Or what do you think?
I think it'd be worth asking the question. It may be because traditionally AAVSO has come from long-term monitoring of things rather than transients. It's come about, you know, long-term light curves, not about things that suddenly happen. Because you can argue things like micro-lensing. You know, where would micro-lensing fit? That wouldn't fit anywhere. There's certainly micro-lensing events happen out there.
Yeah, that's a good point, and that is not by any stretch high energy, I guess.
Which is high energy as the star is behind it.
Right.
Not particularly a change in high energy, just a change in brightness.
Okay, I'll take this to the next next meeting. That's a good point, and. Right in the forum, what was the conclusion of that? Yeah, that's good.
Yeah, okay, well, I think I'll leave you to it then.
Yeah, I guess we wrap it up now.
Yeah, see you in whenever the next meeting is.
Exactly.
Okay.
Oh, have a good night, day, morning, afternoon.
No, it's definitely night here.
Whatever.
I'll go and see if I can see this comet in Orion, if it's clear.
There's a comet. I totally missed that. There's a comet in Orion.
Yes, about Mag 8 or something, just above Bellatrix. I'd have to. I don't know if I can. Hang on, this could be disastrous. I'm just trying to open my my sky chart at the same time. Orion. Yeah, it's it was only discovered fairly recently. See, 2020 M3 Atlas. Which is
2020, what was it?
Mike 3, M3.
Oh,
back it's Atlas. It's another Atlas comet. And according to this, it's magnitude 8.2 at the moment.
Okay, and do they have projections? How? I mean, will it be something?
It peaked yesterday. It's moving quite fast.
Okay.
I think it was 8.1 yesterday, so it's gone down 0.1 of a magnitude. So.
Yeah, you never know with those comets.
Well, I think this is heading away from the sun now, so it's probably just going to fade. But it's.
Okay, cool.
It's just about above Bellatrix,
Yeah, that,
Gamma
that's
Orion, if you like to know.
cool.
Top right hand of Orion.
Unfortunately, the weather here is abysmal, but yeah, sometimes you have a little break in the clouds. And
Yes, that's what we had last night, but I couldn't see it with binoculars. But if you got your telescope there, you might get something.
Yeah, I mean, with 8 magnitude, I should get it with a DSLR. I mean, I get like
We say that's diffused, of course, magnitude, so it's not the same as an 8th mag star.
but sometimes when they have this bright green color, they stand out quite
Yes.
nicely. Cool.
Yes, enjoy.
Yeah, you too.
That's
Good luck.
definitely not high energy.
Yeah. Good luck observing. And
Yes, okay.
clear skies to all of you.
Yeah, okay. I'll see you sometime.
Yep.
Bye then.
Bye.